take it away.
Okay, thank you for the kind introduction. So indeed, my name is Joachim Demuynck and I'm working for ACC, and it's my pleasure to present you some preliminary results of a demonstrator vehicle that we are currently testing. And let me first explain. ACC stands for the Association for Emission Control by Catalyst. And so we represent the European emission control companies you see on this slide. And so we cover a range of mobile applications from cars over commercial vehicles, motorcycles, and non-road mobile machinery. And I think it's first of all important to recognize, let's say, the significant reduction that we are seeing of the most modern vehicles that are coming to the streets, so towards the latest stage in the emission legislation, Euro 6D. And so this includes also the gasoline PN emissions, for which a gasoline particulate filter has been introduced with the introduction of the real driving emission legislation. And here just two, let's say, examples that illustrate that. On the left, you can see data from type approval. So these are PEMS measurements taken from the ASEA and JAMA PEMS databases that are available online. And you see a plot of the urban PN emissions, so measured over the urban part of the RDE test versus those measured over the total part of the RDE test. And you can see clearly both for, let's say, the two most recent stages, Euro 6D temp and Euro 6D, significant reduction in PN emissions compared to, let's say, the levels that were in literature for previous stages. So there's no actual data in the database for this, but so here we took the emission factors from the JRC. And this is also illustrated by a very recent paper by Commission and also CLOVE members about test results of a Euro 6D temp gasoline vehicle under a wide range of test conditions. So different tests, different ambient temperature conditions. And this also showed consistent low PN emissions. So we achieved already good progress, but I think it's even further innovation is to come, and this will come with the next step in the emission legislation, the Euro 7, which will drive further emission control technology innovation. This process is ongoing, so the expert working group established by the European Commission, the so-called ACFES group, has held several meetings over the past years, and including in, let's say, 2021 meetings up to the end of April. That was, let's say, set to be the last meeting of the ACFES working group. In parallel, there have been a consortium called CLOVE Consortium, which is a consortium of engineering houses and academia you see on the right. They have been working on behalf of the European Commission on, let's say, technical input towards the European Commission. And they presented scenarios for light duty and heavy duty vehicles, and will also provide further input for the European Commission impact assessment. Also at the UN level in the PMP informal working group, activities are ongoing which are related. So in PMP, a PN10 measurement procedure is being developed, so to measure PN emissions with a cutoff as of 10 nanometer, whereas the current procedure in place is as of 23 nanometer. And then all this will lead up to the European Commission proposal, so the actual proposal, which we expect to be out there by the end of this year. So we expect the Commission will come out with the proposal end of this year. And this will then be the start of the so-called trilogue negotiations with the other legislator institutions, so the European Parliament and the Council. We as ACC, we are conducting several demonstration programs, both for light duty and heavy duty, where we are investigating ultra-low emissions with then state-of-the-art emission control technologies and really working in an integrated powertrain approach. So it's really the emission control within the powertrain. So together with the engine, also with lubricant, with the correct fluids, and also the calibration of the system to make sure that everything works well together. And we are taking also on board the topic of low CO2 emissions through testing of renewable fuels. So to validate the low pollutant emissions on these renewable fuels, and then to show the low CO2 emissions that can be achieved. Today I will focus on the light-duty gasoline demonstrator vehicle, which is a project which is still ongoing. So I'll present to you some preliminary results and mainly focus then on the particulate number emission. The vehicle that we are working on is a C-segment vehicle, has a 1.5 liter engine with 4 cylinders, some technology like variable valve train, cylinder deactivation is on board. And also we have a 48 volt mild hybrid on board. So this is entry-level hybridization with a so-called P0 configuration. So it's an electric motor which is integrated within the belt of the engine. And so it doesn't allow to run only on the electric motor, but so the electric motor can support the internal combustion engine. We start from a Euro 6D type approval situation of this vehicle, which has a system, a gasoline particulate filter in combination with a 3-way catalyst. And that system we then took out of the vehicle and we put in the ACC system, which I will explain on the next slide. Let me also acknowledge project partners because we're conducting this in partnership with others, and this support is highly appreciated. So we're working together with IAV, IPA, and Denso on this. As mentioned, so we took out the original emission control system of the vehicle and then put in place the ACC system, which is visualized here at the right. So it's a combination of a close-coupled 3-way catalyst with then an underfloor system that consists of a catalyzed gasoline particulate filter, a second 3-way catalyst, and also an ammonia slip catalyst. And we're trying to cover durability up to the extent which is possible in such projects. So we're using bench-aged components targeting 160,000 kilometers. And the lambda control of this vehicle, we're, let's say, working further on what is available in the vehicle as it is on the market as Euro 6D. So there are 2 lambda probes, one before the close-coupled 3-way catalyst, which is a wideband lambda probe, and then a second lambda probe behind the 3-way catalyst, which is then a 2-step lambda probe. We're conducting several tests both on the road and in the lab and have different instrumentation to measure the different pollutants. Just some words on that. So on the chassis dyno, you see it here visualized. We have different sampling points before the 3-way catalyst, in between the close-coupled and underfloor system, and also at the tailpipe. And this includes FTIR and also PN10 equipment. And on the road also we have, let's say, a standard PEMS, but in addition also prototype PEMS to be able to measure ammonia, N2O, and also PN10. Not to go in details here on the specification of the devices, but just to give you some idea on how it's looking like when we are testing the vehicle, and then specifically for the PN measurements that we're doing. So if we are testing on the chassis dyno, you can see here the vehicle then is equipped with the PEMS, so we keep that on board also when measuring on the chassis dyno. So the PN10 data I will show will mainly be from the PEMS device. And then there's a lab measurement PN10, which is then after the dilution tunnel. So it's measuring here. And if we go to the road, then of course we rely on the PEMS result. And that's why I will focus on the PEMS data, because we have that for then both on-road and chassis dyno measurements. In the program, we try to, let's say, cover a wide range of driving conditions to then explore the emission performance over that range of conditions, trying to go beyond also the Euro 6 RDE boundary conditions. And as mentioned, we have a combination of chassis dyno tests and road tests. And we're trying to cover mainly a combination of ambient temperature variation and then also driving style. And this is shown here at the top right for the driving style. So with a parameter called V times A positive. So this is the vehicle speed multiplied with the positive accelerations and then taking the 95th percentile according to how it is done in the Euro 6 RDE legislation. And the red line shows, let's say, for the urban, the rural and the motorway part, what the current RDE boundary condition is within the Euro 6 legislation. And so we are trying to cover a range for the driving dynamics. So from soft, we call it soft or smooth, which are then the data points here at the bottom, over the normal driving on the road, the blue solid circles, and on the chassis dyno, this is the gray triangle here. We label that test as RDE aggressive as it is on the boundary condition of Euro 6. But we then also have aggressive driving on the road, which actually goes beyond, which is here the open blue circles. And we're combining that then together with the ambient conditions. So on the chassis dyno, focusing on the RDE aggressive test, which we are measuring at the standard 23 degrees Celsius test and also at -10 Celsius. And then on the road, of course, there we are a bit depending on the weather conditions, but we try to also have a variation of the ambient conditions. And we were able to collect some data during winter time. So you see that we have, let's say, some tests from -5 up to 23 degrees. And we combine that then with the driving style. You see that we, with the preliminary data that we have, don't always conduct a full RDE test with urban rural motorway as it is prescribed in legislation, but also have a shorter calibration test, which you will see later on in the data. This also has urban rural motorway, but with shorter, let's say, distances than what is in the legislation. Just to give you some insight that we will collect so both PEMS and lab data. Just here some preliminary example of two tests, the RDE aggressive test at 23 at -10, where you then have in blue each time the PEMS measurement, and in orange then the PN measurement from the dilution tunnel. And so we will have some data to look into, let's say, how this correlates with each other. So overall, based on this, let's say, data, we see kind of, within between 0 and 30% for the moment is based on this result, the deviation between the two measurement results. If I give you the overview of the data that we have measured so far, I use a cumulative PN plot for that. So you see cumulative PN emissions over the distance driven during the tests. And as mentioned, we have some shorter tests and also the, let's say, the full RDE test according to the legislation. Then we can see overall ultra-low PN emissions are measured. It has to be noted that we're not checking the most challenging condition for the filter. So as we are using aged components, soot and ash accumulation during that aging actually supports the filtration efficiency. And that's something we will still look at, and I will mention it in the outlook. But what can we see for the PN is actually we see an initial cold start effect, and then for the rest of the test, near zero emissions. And that initial cold start effect depends then on the conditions tested. And if I, let's say, plot, maybe I go back here, the data at a distance of 16 kilometers, so to have a kind of consistent number per kilometer reporting for all the data that we have. If I plot these into this chart, then you can see that we have a variation in number per kilometer over almost 2 orders of magnitude. And that's impacted by a combination of change in ambient temperature, driving conditions, and then also engine out emissions and filter status. So for instance, yeah, the results are plotted here according to the ambient temperature. So we go from 23 degrees up down to -10 degrees at the right. So there is a tendency to have a higher initial cold start peak for lower ambient temperature. And then on top, you also have the impact of the driving conditions. So for instance, if we focus here on the orange bars in the middle, so which are all from this calibration test that we have, you see that from smooth over normal to aggressive, there is a tendency to have, let's say, a higher number per kilometer. And this is because of the impact on the very initial cold start peak. And this yeah, seems to be a bit more important than the change in ambient temperature that we have for these tests. But it's not always so straightforward. So for instance, perhaps we would have expected the -10 degree test to have resulted in the highest PN, but that's not the case. So there's also this impact of combination of then engine out and also the filter status at the beginning of the test, which anyway gives a test-to-test variability, even if you would repeat the same test. So to conclude, we are looking into, let's say, combining close coupled and underfloor components on a light-duty gasoline demonstrator vehicle. Looking into early light-off for gaseous emissions, then for urban emission control, in combination with consistent emission reduction over the range of driving condition, and then specifically for the particulate emissions, measuring PN10 emissions, and these show to be controlled to ultra-low levels over a wide range of conditions. We see an initial cold start effect and then near zero emissions throughout the rest of the test. Gaseous emissions will be covered in a publication at the SAE International Conference on Engine and Vehicles in September. Let's say we're still working on some activities this year. I mentioned the fresh GPF. So as I mentioned, the aging of components actually helps filtration efficiency. So we will look into possible measurements with the fresh GPF to try to see what that result would be. And then also we'll work on further thermal management measures on the system. So by adding an electric heated catalyst to try to reduce the remaining initial cold start emissions. That's more for the gaseous emissions. But perhaps also with the change in thermal management strategy, maybe also PN emissions, engine out PN emissions can benefit from that. We will investigate that. And as mentioned, also the topic of renewable fuels is something we take on board in all our projects, and to really then investigate low pollutant emissions in combination with low CO2 emissions to really have future-proof internal combustion engines. I thank you for your attention and look forward to some of the questions.
Thanks so much. We do have a couple of questions in a couple of minutes. So the first one comes from David Kittleson, and he asks, what fraction of new gasoline vehicles are equipped with GPF, and what fraction of the current light duty fleet would that be?
Okay, thanks for that question. As far as we can see on the data that we have, so this is mainly judged based on that PEMS database of the Car Manufacturer Association, so ASEA and JAMA, that let's say all the direct injected gasoline vehicles that are coming to the European market as of the introduction of RDE, so the Euro 6D temp and the Euro 6D stages, that these are equipped with GPF. So it's really with the introduction of the real driving emission regulation that all the direct injected gasoline vehicles are equipped with a filter. Of course, then how to quantify the fraction of what is that for the current fleet, I'm afraid I don't have such quantification with me. But of course, yeah, it's the new vehicles that are being introduced with that, and then as the fleet renews, this will ramp up in the fleet.
Great. And then Jerry's question is, what are the measurement uncertainties of presented cumulative PN measurements?
So this is something we will still look into. So as mentioned, we report here the values as they have been measured. So there's no error bar around it yet. So this is something we will look into. So of course we have, let's say from the device, we will look into the specifications. Currently, the RDE legislation includes measurement uncertainty estimation for PN of 50%. And the European Commission, the JRC, I think has published some further data on that, trying to understand the impact on it and what are the different parameters with the potential lower estimation then of the measurement uncertainty. So I think that's a starting reference for us, and this is also something we will specifically look into then for the device that we have available, and then the PN10 measurements, because current evaluation, as far as I understand, is done for PN23.
Great, thank you. There's one more question on Slido. If you want to answer that in the chat, that would be great, just for time's sake.